Hi students, in this video we're going to look at how to multiply matrices together. So after watching this video, you should be able to determine whether or not two matrices can actually even be multiplied together. You should be able to determine the order of the product matrix of two matrices. So product just means multiply. So product matrix is just what is the result when you multiply two matrices together. And our main learning goal for this video, you should be able to multiply matrices together. Alright, so matrix multiplication is different to addition and subtraction. So matrices for multiplication, they do not have to have the same order to be multiplied together. But there are some rules that need to be followed. Two key things to understand when multiplying matrices together. So first of all, it's important to know that matrices can be multiplied together only when the number of columns in the first matrix is equal to the number of columns in the second matrix. If those values are not equal, they cannot be added together. So let's say I've got two matrices. The first one, let's say it's got an order of 2 times 2. So that means it's got 2 rows and 2 columns. And I'm multiplying that by another matrix that has 3 rows and 4 columns. Okay. What I'm looking for is the number of columns in the first matrix needs to be the same as the number of rows in the second. So here, those numbers do not match up. They are not equal. Right? The number of columns in the first matrix is 2. The number of rows in the second matrix is 3. Those values are not the same, so these matrices cannot be multiplied together. Now, if we change this first number to a 3, so we've got a 2 by 3 matrix and a 3 by 4 matrix that we're multiplying together, that one can be done because the numbers in the middle, right, the 3 columns in the first matrix match up with the 3 rows in the second that are the same number. So what you're looking for is the same number on the inside terms there. Now the second thing to note is that for a matrix with order mn and a matrix with order np, when you multiply them together, the result has an order of m times p. So that first number times by the second number, that's our new order. So looking at our example here, if we have a 2 by 3 and a 3 by 4, our result matrix will actually be a 2 by 4 matrix at the very end. These two outside numbers give us the order of our result matrix at the end. So let's use this in some examples. We've got two matrices here, P and Q. We need to determine whether or not these product matrices exist, and if so, what will the order of the product matrix, the result matrix, be if we try to multiply them together. So looking at P, that's got 2 rows and 2 columns. That's an easy 2 by 2 matrix. Q has 2 rows and 3 columns. So when we're looking at PQ, we've got a 2 times 2 matrix, we've got a 2 times 3 matrix, and we're looking at those inside numbers, they're the same. So we can say for this one, yes, they can be multiplied. And when they are multiplied, what will the order of the result matrix be? Look at the outside numbers. It'll be a 2 by 3 matrix we get at the end there, just using those outside numbers. Now what about QP? So for QP, Q is a 2 by 3 matrix, P we've said is a 2 by 2 matrix. Looking at those terms in the middle, they are not the same. So we can say, no, they can't be multiplied. Or because the number of columns in the first matrix is not the same as the number of rows in the second. All right, so our steps for matrix multiplication. So first of all, we have to confirm that the matrix multiplication can actually be done. That's what we did in the last example. And we need to determine the order of our answer, of what our product matrix should be. We need to set up the product matrix in terms of its elements. So that's going back to a previous lesson, looking at how we describe elements. And then we need to multiply, and this is the key step. We need to multiply the elements in the first row of the first matrix by the corresponding elements in the first column of the second matrix, then add them together. It sounds a bit wordy. I get that. That's why we'll do an example to actually explain what it means. And then after that, we need to repeat those steps for the other rows and columns in the matrix. Once again, an example will be the best way to go through. All right, so when we multiply matrices together, we want to start off with our result matrix. We've proven in the last example that this multiplication will work because we have a 2 times 2 and a 2 times 3. Middle numbers are the same, we can do it. So, and these last two numbers give us our order. So our product matrix will be a 2 by 3 matrix. And I'm just going to give each element its letter based on its position. So PQ11, PQ row 2, column 1, PQ row 1, column 2, and so on. Row 2, column 2, row 1, column 3, row 2, column 3. And what we're going to do is work out each of those values individually. Now that first one, if we want to find out PQ 1, 1, what we're going to do is match up and multiply the first row of the first matrix, that's the first one, and the first column of the second matrix. What we do next is we will find the first element and the first element and multiply those together. So 2 times 4, that gives us 8. Negative, and then do the same for the second element. Negative 1 times 0 gives us 0. And then we add them together. And that number we get, number 8, will be what we put in for PQ11. So we did first row times first column for 1, 1, and then match up the elements, multiply them together, add them up, and then we get our solution. Do another one for you. So let's say we do PQ, let's this time do 1, 2. So this time we're still using that first column, but we'll multiply it by this time, that first row in the first matrix, and then this time we'll multiply it by the second column. And again, we just match up our terms and go from there. So we've got 2 in the first row, multiply it by negative 2, that first spot in the second column. 2 times negative 2 is negative 4. And then we've got negative 1 times positive 2, that's negative 2. And then we'll add those together. Negative 4 plus negative 2 gives us negative 6. So in PQ12, first row times second column, that unit will go in there. I'll do the next one pretty quickly. PQ13 will once again be first row, this time times our third column. So 2 times 1 gives us 2, and then negative 1 times 5 gives us negative 5. Add them up, and you get negative 3. Now moving on to the row below, so we've got, now let's do PQ, let's use light blue for this one. So row 2, column 1 in the dark green. So this time, instead of multiplying by row 1, we're now going to multiply by row 2, which is this one here. And once again, we'll just match them up and multiply it out. So we'll have 1 times positive 4 gives us 4. 3 times 0 gives us 0. Add them up. And then we can work that out for the rest of our equations. So row 2 times column 2. 1 times negative 2 gives us negative 2. 3 times positive 2 gives us 6. Negative 2 plus 6 gives us 4. And then finally PQ 2, 3. So second row times third column. We'll have 1 times 1 gives us 1. 3 times 5 gives us 15. Add them up. That's 16. And now we can just put those numbers into our original matrix. So PQ11 was an 8. PQ12 was negative 6. PQ13 was negative 3. PQ21 was positive 4. PQ22 was also positive 4. PQ23 was 16. And that's how we do matrix multiplication. A long process, a lot of the same thing over and over again, but it's always just rows times columns. And the number row and the number column you multiply together, that tells you where it fits in your matrix. So after watching this video, you should be able to determine whether two matrices can be multiplied together. You should be able to determine the order of the product matrix of two matrices. And in that final example, we looked at how to actually multiply matrices together.